Okay, hello again class. Let's do the page 116 homework now. My dog wants to be in the video, so I told him that was okay, as long as he kept quiet. We are not going to need our compass or straight edge. Let's get down to business. Alright, so this one here. We're kind of transitioning now from doing dilations to just knowing that two figures are similar and then answering questions about them. This first question here is telling you that triangle HOT is similar to triangle PIG, and they just want to get at this idea about a similarity statement, always listing the parts in corresponding order. So here when it asks you H corresponds to, I wouldn't even look at the picture. I would just look at the similarity statement. You know that H coming first means it corresponds with P because that also comes first. And yes, it's just that easy. So O corresponds with I and T corresponds with G because first letter always corresponds with the first letter. So that means in the diagram over here, H, there might be some confusion about whether it corresponds with G or P. You know that it doesn't correspond with I. You can see that I is a right angle. I pretty obviously corresponds with O. But whether H corresponds with G or P might be a little bit hard to tell until you look at the similarity statement, and then it's obvious that H and P go together, and it's T that corresponds with G. So easy enough. PI is going to correspond with HO. Make sure to put the hat on it because those symbols matter. IG corresponds with OT, and GP corresponds with TH. Now they're saying if the measure of angle G is 12, so if this angle right here is 12 degrees, then what's the measure of angle T? Well, T and G correspond. And in similar triangles, corresponding angles are congruent. So if one of them's 12, the other one's 12. Now that would be a slightly tougher question. If I told you that HT was, 26 inches or whatever, and then I asked you how long is GP, it sure as heck is not 26. Because remember, triangles that are similar, they don't have the same size. They just have the same shape. So you should expect side GP to be pretty much anything but 26. If we expand it, it'll be bigger. If we condensed, it'll be smaller. But the angles stay the same, even as I enlarge the shape. That 12-degree angle is not changing. It's not getting bigger or smaller. So just keep that in mind. Alright, so here we've got two similar figures. Find the scale factor and the ratio of the perimeters from the small one to the big one. So as we go from small to big, the scale factor that we're blowing up by, again, if we're going from small to big, then you want to do the bigger value over the smaller value. So our scale factor would be 9 over 6. But I can reduce that by a factor of 3. So 9 over 3 is 3, and 6 over 3 is 2. So our scale factor would be the fraction 3 over 2, or the decimal 1.5. Now the ratio of perimeters is going to be the same ratio. If the ratio of the sides is 3 to 2, well, the perimeters are based on the lengths of the sides, so the ratio of the perimeters will be the same as the ratio of the sides. So I guess you could give it as 3 over 2 again, but I'm going to give it with that colon notation that we do before. So the ratio from small to big is 2 colon 3. So there you go. That's it. I guess the one thing to point out, I grabbed the 9 and the 6, but we could have grabbed any pair of parts. Notice if we grabbed the 10 and the 15, that 15 over 10, those are both divisible by 5, and when you divide, you still get the same 3 over 2. That's kind of the whole point of similarity, right? Is that the sides are proportional, meaning no matter which pair you grab, you'll always get the same ratio. That's important. Number 3, we want to write our similarity statement. I guess that means they're definitely similar. Remember in the lesson after this, we have to actually wonder whether we're similar or not, and we try to prove it using different methods. But here, I guess we know for a fact that we're similar. So we just want to write our similarity statement. They said ABC. Now A here is this angle that's not labeled at all. I can see that B is congruent to E because they're both 70. So I guess that means A must correspond with D. And that means if A comes first, D comes first. Then they went to B. B is the 70. And if E is also 70, then B and E correspond. So you definitely want to have E in the middle. And then you know you're going to say C last. So there's your similarity statement. They're asking for the measure of angle 1, and there's nothing special here. You can see that that angle and that angle are vertical angles. They're angles across from each other when lines intersect. Vertical angles are always congruent, so we can say pretty confidently that this angle is 30 degrees. Then to find the measure of angle A, well, if we want to find A, I'll put a variable here. We'll put a little lowercase a. Then we know that angle A plus 70 plus 30 has to add up to 180, because all three angles have to add up to 100. So if we add up these two, we get 100, and then 180 minus 100 leaves 80. So angle A has to be 80 degrees. Then they want to know the measure of angle D. Well, we already decided that A and D were corresponding parts, so they are, well, they're corresponding angles, so they're congruent. So this one's 80. Now they're saying write me a proportion to find x. Writing a proportion means you write a ratio and you set it equal to another ratio. And if you're trying to solve for x, then you pretty obviously need to include the side whose length is x. Now BC comes second and third, so that must correspond with EC, so the 10. So I know that one of the ratios I want to write is going to be x over 10. Now I need a second ratio, and I'm pretty sure I'm not going to want to go with the 6 and the 9, or the 6 and the y, excuse me. Those are corresponding, but if I use 6 and y, then I'm putting a second variable into my equation, and I can't solve equations that have two variables in them. So I guess that means I should focus on this 9 and 12. Those are corresponding parts, and I know both of their values, so I can take that and plug it in. So we did x over 10, meaning we were working from this triangle to this triangle, so we want to do it the same way. We'll do 9 over 12. Now the way you solve a proportion is you multiply on one diagonal, multiply along this other diagonal, and you set the two results equal to each other. So we're going to get something equals something. So when we cross multiply, we get 12 times x, so this side can be 12x. When we cross multiply here, we get 10 times 9 is 90. It doesn't matter which way we went. If we did the 90 first and was equal to 12x, it wouldn't matter, because the next step is just going to be to divide by 12. So whichever side we had these things on, we're going to end up with x being whatever 90 divided by 12 is. And 90 divided by 12 should be, if you guys bust out your calculators, see, give me a second, 90 over 12 is 7.5. So you could give me that as a decimal. You could also, if you felt fancy, make it a fraction. So 15 over 2 is an acceptable final answer, but 7.5 is fine too. I assume most of you will just go with 7.5, and that's fine. So we'll get rid of that. So 7.5 is great. Alright, so now it wants a proportion that will allow us to solve for y. So we're going to do the same deal. Literally the same deal in the case of 9 over 12. That ratio there still works for us, so let's keep that ratio. But now we want the y side. And the y side, I guess in pink, the y corresponds with 6. But again, make sure you keep your parts in corresponding order. So when we did 9 over 12, we were doing, the left side triangle divided by the right side in that order, left over right. So that means we got to go 6 over y in that order. 6 has to be in the numerator. Y has to be in the denominator. But now that we're set up correctly, we cross multiply. 6 times 12 is 72. 9 times y is 9y. So if you divide by 9 now, divide by 9, you get 8. And those are your two answers. Okay, that's it. So we can do 4 now. And I'll start to work a little faster now because I talked about these ones at length. Hopefully you understand the deal. Let's do this now. So they really wanted you to notice here that when we had the 70 here and the 70 here, that meant our triangles fit together in a certain way. the 80 is here now and 80 is here now. So these triangles fit together a different kind of way. So when I go to name them, they said TBM. So T to B to M, that's like this. Well, we don't have the same reflectional symmetry that these guys had. Here when we said ABC, when we said ABC like this, we kind of reflected that over to get DEC. And that's because the 70-degree angle reflected over onto the other 70-degree angle. But here, this 80-degree angle is really rotating onto the other 80-degree angle, which means the way we write our statement is going to change. They've said T to B to M. We need to go from A to B to C in that order. It's more of a it's a rotational symmetry this time that maps these things together. Again, the easy way to think about this is the M for sure corresponds with C. So they put M at the end. I'm getting this wrong. I'm sorry. I should be looking up here. I'm looking at TBM, but let me look at ABC. The A does not correspond with M. M corresponds with C. So with a C at the end, you know you're putting M at the end. The B's pretty clearly still correspond. So the middle is B, so our middle should be B. And then it's angle A corresponds with T, so T should be first. So when they told us ABC, we knew that we needed to say T, B, M in that order. Then once you've got that, the rest is cake. It says angle A corresponds with, we know that it goes with T. It says angle TBM, it's going to correspond with ABC. And you know what? I'm being lazy. Let me not be lazy, because I would mark you down if you guys did this. So if it says measure of angle A, make sure that you say measure of angle T. And if they say measure of TBM, make sure you say the measure of angle ABC. You want to match the notation you're given. That's basically the safe way to go. And then finally, angle T corresponds with A, so the measure of angle T. All right, now we're doing math again. So to solve for x, we want a proportion. Hopefully you guys can tell that x over here corresponds with 6. That's pretty clear. And then the 21 and the 14 are the ones that go together. Notice again, the 9 and the 12 went together and they sort of reflected onto each other, but the 12 and the 21 and the 14, they rotate onto each other. So it's kind of a different relationship there. But let's grab the x and the 6. I'm going to go x over 6. Then let's grab the 14 over 21. And then there's my proportion all set up. Again, remember, because the x and the 14 come from the same triangle, they should both be on top or both be on bottom. The rule is just that measurements from the same triangle should be on the same side of the fraction. Either they're both up top or they're both down below. So we're cross multiplying. 6 times 14 is 84. And 21 times x is 21x. If we now divide by 21, we get x equals 4. That's it. To solve for y, we have to find y. Here it is. And we see that y corresponds with 10. So this time we'll set up a proportion where we've got y over 10 as one of our fractions. And then we want to use the 21 and the 14 again. But again, notice I put the y into the numerator. So it's the 21 that should go in the numerator. And the 14 will go into the denominator. So that's different. The first time I had 14 over 21. This time I have 21 over 14. And that's fine because I swapped the other fraction. Anyway, let's do it. 21 times 10 is 210. And 14 times y is 14y. Now you'll divide by 14. You'll get y equals. Now I'm not sure what 210 over 14 is, so we'll go back to the calculator. It's 15. So that's it for that. So there you go. We wrote our similarity statement. We paired off corresponding parts. We wrote proportions, and we showed our work to get to a final answer. Make sure you know how to write the proportion. Make sure you know how to cross multiply to get your final answer. If you do the work in your head, don't expect to get credit. You have to have work shown. All right, so same deal here. We've got these similar rectangles that's going to have all the same properties that similar triangles had. It's going to go ahead and, that's a little bigger than I want it to be. Sure. So the 5 corresponds with the 3. Now that looks right to me. You can tell the long side should go with the long side. But if the figure wasn't drawn to scale, you still might want to be double checking. So this side is DC, that's 4th and 3rd. So it should go with WT, and it does. So everything is as I expected it to be in terms of corresponding sides. So you got the 2.5, you got the W. This should be a prime problem where you guys can pretty easily see that 2.5 is just half of 5. So x should just be half of 3. It should just be 1.5. Yeah, I can do it in my head too. But you're not going to get credit if you do it in your head. So remember, you must set up the proportion. Show me that you're taking the 5 and the 3, you're turning them into a ratio, and you know that that ratio of 5 over 3 has to equal the ratio of 2.5 over x. Now you're solving by cross multiplication. So 5 times x is 5x. 3 times 2.5 is 7.5. Then you divide by 5 and you get 1.5. Alright, yeah, I agree. The answer is 1.5, but you have to show the work. So don't skimp out. Okay, so here's another good one. Here it might be significantly harder, or at least legitimately a little bit harder to tell who goes together. So my trick before was that you always know that the smallest part of one triangle goes with the smallest part of the other triangle. So that would be the 4 and the, well, geez, I don't know, because they're labeled J and K. So we can't use that trick that I was talking about in class about smallest goes with smallest. So the other trick then is to remember, if we have AB, AB is going to go with FE. So FE is the 10. So if you would assume that the 4 went with the 10, you're right. Then from there, you probably are assuming 6 goes with K. Let's just be sure. 6 is AC. AC is 1st and 3rd, so that's FD. So yeah, those are the guys. And then the 3.8 goes with the J. So with all of those values matched up and corresponding, we know that we're going to write proportions that involve the 4 over 10. That's our similarity ratio. And then if you're solving for J, then you'll grab whatever corresponds with J. You'll put the 3.8 in the numerator, the J into the denominator. Now this is correctly set up. So we solve by cross multiplying. We get 4 times J, and 10 times 3.8 is just 38. So you divide by 4. And I don't think this comes out cleanly. We get J equals, what is it going to be? That's half of 38 is 19, half of 19 is 9.5, so this must be 9.5. Just use your calculators. Alright, to solve for K, again, we set up basically the same proportion. I still think you're using the 4 over the 10. And then to solve, this time we're using the blue sides. So it's still going to be 6 in the numerator and K in the denominator. So cross multiply this time and you get 4K equals 60. And this time K does come out nicely and cleanly. It's going to be exactly 15. And that's it. If I'm giving you guys lines to put your answer on, put your answers there, please. It helps me grade faster. This is 15. But there you go. That's 6. 7, I'm going to say let's do the same thing. Let's match up our sides. I think it's pretty clear that the longest goes with the longest, but they're not even marked, so that's not helpful. Then you've got this 14, and it's pretty hard to tell. I mean, 14 is certainly a bigger number than 9, But who's bigger, x plus 8 or 2x? You really can't tell. So whether 14 corresponds with the x plus 8 or the 2x, you really don't know until you look at the similarity statement. So really remember that that's something you have to do. So df is first second, so it's going to go with TP. So it actually isn't this one, it's this one. Again, why is that? Well, because these figures either fit on top of each other by sort of a reflection. If it was a reflection, then 14 would map onto the x plus 8 and 9 would map onto the 2x. But it doesn't have to be a reflection. These figures could have fit together by a rotation around this point. And then the 14 would rotate around to the 2x, and the 9 would rotate around to the x plus 8. So just remember, again, there's really no way to know exactly who corresponds with who unless you look at the similarity statements. So it's definitely df corresponding to TP over here. It's the rotational symmetry, not the reflectional. And that means the 9 corresponds with the x plus 8. So this means when we go to write our proportion, I've been coaching you to, find a pair of sides where you already know them both, but we don't have that. We've got 9 corresponding to an x plus 8, and that's fine. We can solve. We'll do 9 over x plus 8. And then our other ratio is going to involve x also. And I told you we couldn't solve if we had more than one variable, but we don't have more than one variable. We just have the same variable twice, and that's okay. That's not a problem. So we cross multiply. 9 times 2 is going to be 18, so this is 18x. When we cross multiply here, we have to remember to distribute the 14, so we get 14x plus whatever 14 times 8 is. That would be 112. So now, since I've got x's on the left and some x's on the right, we're going to get rid of these x's by subtracting on both sides. That's going to bring us to just 4 x's that equal 112. So now we just divide by 4. 4's cancel, and you get an x that equals, I don't know, 28? I think it's 28, but let's be sure. (112 over 4). Yeah, 28. Okay, cool. So put it on the line. I'm giving you a line. All right, easy. Let's do 8. So 8 is saying triangle ABE, meaning the little guy, is similar to ACD, meaning the bigger one. And again, I strongly recommend that when you've got two overlapping triangles, you pull them apart. So here's a smaller triangle in red. Here's the larger triangle in blue. I strongly recommend that you copy them down again. So you've got this bigger blue figure, then you've got this smaller red figure. And now that they're pulled apart, I can label the sides and get a better sense of it. So they're saying AB is 6. AB is the side of the short guy. That's 6. It says BC is 3. BC is just this little piece. So if this is 6 and this is 3, then notice 3 is not part of the red triangle or the blue. What we know instead is that the long side of the blue triangle is 6 plus 3. It's going to be a total of 9. So fill that in accordingly. Then it says BE is 8. BE is the bottom of the red triangle, so that's 8. They're saying find CD, that's this, so X. So there you go. Basically now I would ignore the original figure that they gave you. And so basically just act now like what you have is two triangles that were separated all along, and these are the measurements you've got, and then everything will be easy. I'm not going to really, cover this, but I'll bring it back as a ghost. Well, I don't know what I'm doing. There you go. So it's partially covered. You're ignoring that. Just use this thing here. So again, who corresponds? The 6 corresponds to the 9. The 8 corresponds to the x. So we can set up a pretty simple proportion. We're going to, oh boy. Our proportion is going to be the 6 over the 9. And that's going to equal the 8 over the x. So 6 times x is 6x. 9 times 8 is 72. Dividing by 6 gives us an x that equals 12. And that's it. Yeah, all they wanted was the length of CD. So for this problem, CD equals 12. Okay, now this problem is the same diagram, just different values. So our values are going to change. So as we do part B, AB is now 12. So where this said 6, it should be 12. BE is now 8. BE is the bottom. So that's 8. That didn't change. BE was 8. BE is still 8. But they're saying CD is 10. So that means this is 10. They're saying solve for BC. Well, BC is this part. So that's what we don't know. What else did they tell us? BE was 8. 10. Okay. Alright. We got two choices. My preference would be that if this is 10 and this is 8 and this is 12, then we got two choices. We could label this side as, I'm not going to say x again because that's already x, but what if I called this like, I don't know, w or y? Let's just say y, right? But you could solve for y, and then y would be this total measurement. And then y will be some number bigger than 12, and you know that BC will just be whatever y is minus 12. And you could find the answer in like 2 steps. I don't think that's what I want to do though. I think I want to go ahead and just say that that vertical dimension there from top to bottom is 12 plus x. So that means this side of the blue triangle is 12 plus x. So now we can just write a proportion that has x in it. We can just solve for x directly. So I'm going to do that. So let me make room. We'll start again over here. We know we're going to do 8 divided by 10 for that first ratio. Then we'll do 12 divided by 12 plus x. And we cross multiply, we get 120. Then we distribute the 8 in, we get 96 plus 8x. And then to solve, we got to subtract 96 from both sides. Those cancel. 24 equals 8x. So now just dividing by the 8 should get us to a final answer of 3. And that's it. Right. Is there another problem, or are we done? There's another one. All right, and it's another one of these overlapping triangle problems. So my advice, as always, is draw the big one, draw the small one, and then label all your parts accordingly. So it says AE is 6. AE is just this little dimension, so that's going to be on the little guy right here. It says ED is 18. ED is this piece. So if that piece from here to here is 18, and EA was 6, then what we know is that this dimension of the red triangle is 18 plus 6. So this dimension is 24. Then it says AC is 12. That's the total length of the red, so that's 12, and I don't have to mess with that. Now they're saying find AB. AB is just this little guy, so call it X. And then everything looks pretty straightforward to me now. We can see that the 24 corresponds with the 6. We can see that the 12 corresponds with the X. Moreover, again, if you guys are good at the whole scale factor thing, you can see that we're just working with a scale factor of 4. So if we multiplied 6 by 4 to get 24, then you know that the number that you multiply by 4 to get 12 is 3. So yeah, the answer is going to be 3. That's not important though. What's important is writing the proportion. So again, remember, you have to actually write me a rule. Even when the numbers seem super obvious, you still have to write the rules. Okay, so I'm going to set up a proportion where I've got a 6 divided by 24. And I know that 6 divided by 24 has to equal x divided by 12. And just quickly cross multiply. 6 times 12 is 72. And 24 times x is 24x. So you divide by 24. And 72 divided by 24 is indeed 3, like we thought it would be. So there you go. Now are we done? Yes. So that's it for 116. We can move on to 119 in a minute. I'll see you guys over there on the next video. Bye.